Hello everyone, welcome back to the 5 Minute Tech channel. Today we will continue on our journey for C# design patterns. This is part 5 of the series, and today we will be talking about a behavioral pattern, which is the strategy pattern. So let's get started. So as you have seen, this is the full list of the design patterns which we will be talking about, and today we will be discussing more on the behavioral pattern, one of the behavioral pattern, which is the strategy pattern. Strategy pattern, the intent of the strategy pattern is to define a family of algorithms and encapsulate each one and make them interchangeable. So you have a specific set of specific code which you want to encapsulate and then make it interchangeable. So that is what strategy pattern is about. Strategy lets the algorithm vary independently from clients that use it. So we'll delve more deep into it. Strategy pattern UML diagram, and the context maintains a reference to one of the concrete strategies and communicates with this object only via strategy interface. So context will only talk to the strategy through a particular interface. And there are different kinds of strategies. So what is I strategy, or the interface for the strategy? I strategy interface is common to all concrete strategies. It declares a method the context uses to execute a strategy. Now, different concrete strategies implement different variations of an algorithm and the context uses, and the client is the one which can directly call a particular strategy object, pass it to the context. The context then exposes a setup which lets client replace the strategy associated with the context at the runtime. So all this is happening at the runtime. So now let's get into the demo part, wherein I'll show you an example of data formatter, wherein I will use CSV, JSON or XML formatter at the runtime from the client call itself. So here we are in the Visual Studio right now. I'll create to begin with, I have already created a console application, and it has one specific class which is strategy. Just named it for lack of better class name, and here I will create an interface, public interface I data formatter, and I'll have a method inside this, and I will use something like a data and the data inside that. So now we'll go ahead and create the data class, public class data, name is fine, value, type, interface, public I data formatter, and then we will have the constructor public data. This will contain the and now I will go ahead and do a public void format. Let me do that formatter the format this. So this class is what I will format. Now let's write the different types of formatters. So let me go here, and we have defined the interface. Now let's define the implementation, public class CSV formatter I data formatter, and then we will do is public, we will implement this interface. So implement interface. Soon as you do this, you will get the implementation. Just we'll do a console.log for demonstration purposes, console.writeLine, writeLine, and we will mention is from CSV formatter. CSV formatter. Similarly, we will do for XML and we will do for JSON. So XML and we will do JSON. We will just change it to void, as we are not doing anything specific here in terms of return, so that we just have the console.writeLine, so there is nothing that we are returning here. So now the time is to call this specifically at runtime as we create a data object. So let's create one. Let's remove this and create an object of data. So where data is equal to new data, and we just pass the data in this one, and the name is Manish, then value is test, and type is XYZ, for example. And then let's data dot formatter is equal to new. So if you see here, we have data dot formatter, right? So this is our formatter, new CSV formatter, and then what we will do it is data dot format, and this should give us the implementation there. Similarly, we'll do for all three, and then we will do a console dot read key, and this we will change with the XML, and this is JSON. Okay, we are all set. We'll just run this now, and let's see. Okay, so we are getting all the CSV formatter 3 times, and the reason is in this one we haven't changed, so let's do that, and let's now run this one. So rerunning this, we should be able to get the 3 different formatters. So this is the practical implementation of a particular strategy pattern. When you have more if conditions and you want to break it into specific strategy and call them at runtime like this, then you can do this kind of strategy pattern implementation, where you have an interface which is inherited by different types of strategies, and that is called by a particular context, which is our data, and then it does a specific operation at the runtime as the client needs it. So when to use the strategy pattern? Use strategy pattern when you want to use different variations of variants of an algorithm in your code within an object, and be able to switch from one algorithm to another during runtime. Use strategy when you have a lot of similar classes that only differs in the way they execute some behavior, and use this pattern to isolate business logic of a class from the implementation details of algorithm that may not be important to the context, the data class which I was showing you. How to implement strategy pattern in the context class? Identify conditional scenarios that selects and execute a variant of the same algorithm at runtime. So there was a condition wherein with different formats we needed, so that is something which you can identify. Declare the strategy interface, like we defined the I formatter common to all variant of the algorithm, and one by one you can extract all the algorithms into their own classes They should all implement the interface which we implemented. In the context class, add a field for storing a reference to a strategy object. The context may define an interface which lets the strategy access its data. So we were able to access that particular interface object, and then we can trigger a particular formatter which we wanted. The clients of the context must associate it with a suitable strategy that matches the way they expect the context to perform their primary job. Now, use cases of strategy pattern is in something like a compression algorithm, different kinds of algorithms you are trying to implement, payment processing, different types of payments are there, travel booking systems, different options that comes in, different kinds of bookings which our user wants, and the AI in the game design. Pros and cons of strategy pattern: it offers alternative to subclassing of your context. So in our case, if data was subclass, that also would have worked, but we went for strategy pattern. Open close principle: new strategies can be introduced. Now consider tomorrow we have XYZ formatter, and that could be implemented without editing the data class. It eliminates conditional statements. And then the negative, on the downside, it is overhead in communication between strategy and the context. The class, the client should know about the strategy, and the client injects the strategy, so it must be aware of how the strategy differs. Additional objects are introduced which increases the complexity. Now, related patterns to strategy pattern are flyweight, bridge, state, and template method. Flyweight is a strategy object makes good flyweights, whereas bridge and state are also based on composition, but they solve different problems. Template method, it allows varying part of an algorithm through inheritance, a static approach. Strategy allows behavior to be switched at runtime via composition, which is a dynamic approach. So that was all about the strategy pattern. I hope you like the video. If you like, give you a thumbs up and subscribe to the channel. Have a nice day. Bye bye.